this project, we're trying to cover the whole additive manufacturing process, from designing and printing to characterizations and specifically rapid fatigue evaluation of additive manufacturing parts. The time-consuming and costly nature of conventional fatigue investigation methods is a major barrier in the way of having a full understanding of fatigue mechanism and fatigue resistance in additive manufacturing parts, specifically at the component level due to the complex stress conditions at different sections of the component and also complex test setup and fixtures. We developed and modified a novel rapid fatigue testing method called the Stiffness Method to evaluate the fatigue resistance and mechanism in a topologically optimized fatigue demonstrator component produced by laser powder bed fusion additive manufacturing with aluminum powder. The fatigue limit was estimated by only 2 to 3 tests in 1 day of testing time, with less than 10% deviation from the results obtained by conventional fatigue testing methods. As a result, we saved 90 to 95% in time, cost, and resources required for fatigue investigations. Also, by the use of different characterization methods such as scanning electron microscopy, fractography, and also finite element method simulations, we were able to investigate the fatigue mechanism and also fatigue limit stress level at the weak section of the component. Developing accurate and reliable rapid fatigue test methods such as the Stiffness Method can benefit several industries that use and print additive manufacturing parts such as aerospace, automobile industry, and also energy sections by a reduction in the cost, time, and resources required for a full fatigue investigation. In general, we believe that the whole society can also benefit from these types of accelerated testing methods by a reduction in energy consumption in testing and also by producing high quality additive manufacturing parts.